And now let me show you some examples regarding data preprocessing in PyCaret. As I mentioned, it will be only an example because there are many opportunities in PyCaret regarding data preprocessing, and I will show you all of the opportunities in the next video. So it's only an example. Let's see that. So we begin with importing Python libraries, packages, and after that we import dataset, which is the creditcard.csv. After that we check whether this dataset is imbalanced or not, and we can see it's highly imbalanced because we have less than 500 fraud records, and we have more than 200,000 not fraud or zero labels. So the best would be to keep all of them, all of the 0 and all of the 1 labels, but 1 labels are very important, all of them, for us. But regarding the calculation time, if we keep all of the 0 labels, the calculation time will be very high. Therefore, I made some undersampling, so I drop random records with 0 labels in order to optimize the calculation time. And after that, we get raw data, train and test set, and we are doing this with a custom function. It's a get raw data, and it's from the utils. So it's a custom function from me, and it's good if there is functions in the utils module which are used multiple times. So get raw data doesn't have any parameters, but it returns df train and df test sets. So it imports the credit card CSV dataset, and after that, because we want to use only a subset of this dataset, we want to shuffle this. And the best method if we are using a random state, because in that case, for example, if we restart our Jupyter notebook, we can use same subset of the original one. And now we are creating df0 dataset. It's a reduced dataset, and we are using all of the 1 labels. It's in df_1 dataset, and after that we concat them, and we are creating a train and test split, and we got df train and test sets. Okay, back to the Jupyter notebook. We check now the labels again. We can see that it's still imbalanced. It's no problem, but the rate of imbalance is not very high. Okay, the next step is the following. We want to create a very baseline model, even without any data preprocessing. And after that, we will try out several different data preprocessing steps, one by one. Okay, so let's see the setup function and its parameters. Setup function is very used in PyCaret. There are many different parameters of that. Data and target parameters are required parameters, but all of the other ones are optional. Log experiment parameter equals true. It's great if we want to see the historical results, and PyCaret and MLflow can work together very well, because PyCaret has many different experiments and MLflow track them, and if a log experiment is true, in that case every experiment will be tracked. And if you give the experiment name, you will be able to detect your specific experiment. You can use GPU if you have in your computer, and you can add metric, a custom one. It's great because there are different default metrics, but you can add another custom specific metric. And we are using compare models, and we calculate this. And it's very important step, because there are inferred data types here. So PyCaret try to find out the data types of the different columns. All of them are numeric, and the target is a label. So it's good. I have to push an enter, and after that it can calculate the results. And it's a great table for you, because you can see many good information here. Session ID, the target types, it's binary, the original data, shape, missing values are there or not, numeric feature, numbers. Okay, but now we are not able to see that because it's done. So it's great if you want to ensure that your inferred data types are correct. But if you calculate many times with different setups, it's very inconvenient to push a button every time. So in that case, silent equals true will help you, because in that case we don't have to push button. Okay, and during the calculation, we can see other things here in the table: high cardinality features, transform train set, and test set, shuffle is true or not. CPU jobs is -1, so all of them are used. Use GPU, yes. Log experiment is true. So all of the parameters can be checked here. Okay, and you can see the result for every model, every machine learning model, which are used here in PyCaret. You can use, by the way, custom models. Now you have results, and we want to use the APC metrics, and we can see it's now 0.949, so it's about 0.95. Okay, so it's the result of our baseline model, and we try out different data preprocessing tasks. For example, here this setup is almost same to this, but we try to fix imbalance with fix underscore imbalance equals true. Okay, and if we calculate that, we can see the best APC is 0.957 with extra trees classifier, but the best one here was the light gradient boosting machine, so light GBM. So it's interesting that the order is changed. Removing outliers. Now we want to remove outliers. We want to try only this data preprocessing step, and you can see the APC is worse. And the transformation. Here you can see the transformation, the data preprocessing task, and the result of this APC. You can see the feature interaction, results, So it's a little better than the baseline, our very baseline model. Polynomial features, it's a great APC feature selection. So you can change, of course, many parameters. For example, this one. And it has also very great APC, removing multicollinearity. It has also good APC, PCA, so it's a little better than the baseline model. And our selected model, I selected the best data preprocessing tasks based on these few experiments. But of course, it's just a very short baseline creation. So if you have budget and if you have time to try out many different things, I highly recommend it for you, because there are many different possibilities in data science field and also in PyCaret. So please try out many different things. Okay, thank you guys, and after next I will show you other opportunities in PyCaret. But I would like to say just another sentence that you can see LightGBM was the best here. It's almost 0.96. But for example, in case of PCA, the logistic regression was the best. In case of removing multicollinearity, the extra trees classifier was the best, and so on. So in many cases, different machine learning models are the winner. Therefore, we don't want to see that this APC is better than all of them, okay, all of the experiment results. Okay, thank you guys, and let's see now the other functionalities, other opportunities regarding data preprocessing in PyCaret.